Hello and welcome to this lesson about using proportions to solve problems. The learning target for this video is using tape diagrams and equivalent ratios to solve problems. So let's talk about tape diagrams. Tape diagrams, I believe, are called tape diagrams because when you end up drawing them out, it kind of looks like a long piece of tape. Because what you do is you kind of let a long rectangle be broken into different sections, which with each section representing sort of a component of the ratio, a portion of it. And so maybe you remember in a different video, I drew something that looked something like this, where we had a bunch of different marbles in a bag. And then we talked about how to find the ratio of the different marbles. We talked about part to whole and all that other fun stuff. Well, tape diagrams are incredibly useful for visualizing situations like this. And we have two types of tape diagrams. Two types. First one is we have one long one. And so what we do is we take our portions and we go, we have two blues, we have three reds, 1, 2, 3, and we string them all together with those four greens as well. Now, these are great when we're talking about part to whole. So remember how there are two types of ratios? We have part to part and part to whole. This is great because you can see how they all come together and how there's 9 pieces. So it's great for visualizing, how this impacts those different components. The second kind that we have is mini tape strands, or mini tapes. And so here we just stack them on top of each other. We take our two blues, our three reds, and our four greens, and we stack them up on top of each other like this, so that we can kind of see how they all compare to each other. So there are times and places where maybe you want the one long diagram one, or you want the mini tapes. But I wanted to show you because this is a great visual tool to have in our tool belt when we're solving these problems. So now let's talk about how to actually use them. Now when we're going to do this, this is definitely not the official mathematical phrase. We're going to use a technique I like to call the copy and paste technique. Alright, what we're going to do is we're just going to copy our tape diagram to help us solve a problem. And especially if for whatever reason, and it happens to me all the time, where I just can't seem to wrap my mind around the problem and what's going on, drawing a picture just really helps. And so this is a great visual aid that really help us take something complicated and make it a lot easier. So let's take a look at this problem here. The ratio of boys to girls in a class is 3 to 2. Now notice how I'm kind of labeling these or using different colors. You won't always be able to do that, especially like if you're in class and you just have pencil and paper kind of stuff, but it's good to know how you're setting these up. Anyways, ratio of boys to girls is 3 to 2. Find how many boys are in a class if there are 8 girls. Okay. Well, let's see here. I'm going to take my ratio, 3 over 2. Whoops, let me do it like this, 2. And I'm going to use a tape diagram. So I'm going to visualize it as 1, 2, 3, 1, 2. Now what I'm going to do is I'm going to copy and paste this. So I will copy 3, 2. And right now, in this second version of it, I have 6 boys and 4 girls. Not what I wanted. So again, I'm going to copy and paste. 1, 2, 3, 1, 2. And now in this version, I have 9 boys, 6 girls. I'm going to clean that up. That looks bad. 6 girls. Looks a little bit better. Still not what I wanted because I'm going for 8 girls. So finally, I'll copy it one more time. 1, 2. Now I have that 8 girls, the 8 girls I wanted. And I can then look at this and I can count how many boys there are. 3, 6, 9, 12. I've solved the problem. There are 12 boys in this class if there are 8 girls. And all I did was copy and paste a drawing. So that's one of the neat advantages of tape diagrams. You can do stuff like that. And that leads to a conversation about equivalent ratios. Now, equivalent ratios, or maybe a better word for it, would be a proportion. And a proportion is two ratios set equal to each other. And what we're going to be using a lot with this is multiplication. Multiplication helps us find missing pieces. So for example, let's look at the problem we talked about earlier. We have a ratio of 3 boys for 2 girls. Now, I like to occasionally put in some variables just to know, so that way I know what I'm talking about. 3 boys and 2 girls. And I want to find out how many boys there were in a class if there were 8 girls. Now notice, I have girls in the denominator, meaning that I'm going to have boys in the numerator. This is called consistency, where I'm setting it up the same. Boys up top, girls on the bottom. I could easily flip it, and that's fine. I just have to be consistent. And now, I'm going to change this to the word multiplication, or at least an abbreviation of it. We're going to ask ourselves, what do I need to multiply this by to get 8? Well, I have to go 2 times 4, I can get 8. I'll do the exact same thing here. 3 times 4 to get my answer, which is 12 boys. Now, let's kick things up a notch. Let's look at more problem solving. Here, I have to give you some unfortunate advice. When it comes to doing problem solving, the first step is reading. And I know, that seems like an ELA thing, not a math thing, but trust me, it is. And as you're reading, you want to ask yourself, are we doing part to part? Or are we doing part to whole? Because that's going to change your tactic and how you're going to do it. Second thing we got to make sure we do is just set it up correctly. So that goes back to what I was talking about on this screen right here, where I'm setting things up. Boys up top, girls in the bottom. All right, so now let's take a look at our first problem here. If the ratio of parents to siblings at a high school basketball game is 6-1. If there are 30 parents, how many siblings are at the game? Well, I don't see anything about the total. That seems to be completely absent. So what that's telling me is that this is a part-to-part ratio. So I have, I'm going to do some different color now, 6 parents for every 1 sibling. I have 30 parents, so I'll put 30 up here, and I have to figure out what goes down here for how many siblings. I play the multiplication game. What do I have to times 6 by to get 30? Times it by 5. Here, I'll do the same thing and times that by 5, and I find out that my answer is 5 siblings. Now, just to highlight it, reading is crucial, because if this got switched, how many siblings, or there are 30 siblings, how many parents are at the game, that changes what the proportion would look like. Now, I still have 6-1, parents to siblings, but instead of putting 30 in the numerator, I will put 30 in the denominator. Because I was told there's 30 siblings, and now I have to figure out how many parents there are. And I still play the multiplication game, but it just changes my answer, because now I'm timesing things by 30 instead of timesing things by 5. So here's where reading and setting up are crucial. Alright, now let's take a look at this one. The ratio of parents to siblings at a high school basketball game is still 6-1. If there are 42 people at the game, how many siblings are at the game? Now this is a key piece of information. That's a total value. That's how many people there are in the gym. So this means that I'm dealing with part to whole. So what I can do here is I could use tape diagrams if I wanted to. I have 6 parents for every 1 sibling. And then let me put P right there. and this is equal to 42 people total. Now, if I wanted to, I could copy and paste this a couple of times and kind of keep a running tally of how many people I have. So here I have 7, here I'd have 14, and I could keep going, 21, 28, so on and so forth, and I could count everything up like that if I wanted to. Or I could use math to help me out. I realize that by doing the tape diagram thing, that I have a total of 7 people. I gotta ask myself, how many times does 7 go into 42? So what I can do is take this total and I can divide it by the whole. From the idea of like ratios of being part to whole. And when I do that, I'd end up getting 6. Now, I just take a look at my ratio. There are 6 of these groupings here. So there'll be 6 of them. And that means I'll have 1, 2, 3, 4, 5, 6 siblings when it's all said and done. So that's one way to do it. And if you want to, you could actually draw out all the tape diagrams. So good luck with your homework or practice, and let me know if you have any questions.